myself Drashti Parikh and my student ID is 10141988, and today I'll be explaining the Python assignment 1. So I'll explore the questions related to the data set and build and train a neutral network and analyze the results. So I'll start by importing the necessary libraries. So I'll just run it, and then I'll load the Fashion MNIST dataset. So I'll run that as well. Yeah, so moving on with the question 1, which asks what are the dimensions of train images, train labels, test images, and test labels. So I'll just print it. So as you can see, these are the dimensions. Moving on to question 2, the lengths of label. The lengths of train labels and the test labels are 6000 and 1000 respectively, here as you can see. And then moving on to question 3, which told to show some train and test labels. So I'll just print them. So as you can see, these are the labels here. Moving on to question 4, please show the digital content of image index 5 in the training set. So using the train images method, I used 5 as an index, and it printed me the index image at index 5 for the training. And then it told me to plot the same thing. So by using the train images and plot.show method, here is the image which came. Now moving on to question 6, what is the label for index 5 in the train label, and looking up in the above list, and what does it mean? So yeah, here I name label 5 as train labels index 5, and these are the categories. So after that, it gave me the solution that label for index 5 is pullover, the second one. Moving on to question 7, please show the digital content of image index 500 in the testing dataset. So yeah, this is the index image at index 500, and the same thing after using plot.show, this is the image that it gave. Moving on to question 9. So for question 9 and 10, I imported the libraries as you can see here, and yeah, and then question 11, reshaping and normalizing the data. So over here I named a sequential model by the name my network, and then I reshaped as told in question 12. I reshaped the images from 28 by 28 to a column with 784 neurons, sorry. So yeah, and then question 13, I'll run it. It told me to normalize the image by dividing the image by 255. So yeah, then question 14, I'll run it. It told me to add one hidden layer that has 512 neurons using the ReLU activation function. So yeah, now moving further, we'll go to question 16, which told me to add the last layer as 10 neuron dense, and then it also told me to explain the softmax. So why softmax? Because it converts the raw scores into probabilities, ensuring the sum of probabilities for all class equals to 1. This helps in multi-class classification by predicting the most likely class. That's why we use softmax. Then this is the summary, my network.summary. So this was a sequential model, as you can see. And then moving on to question 17, here I trained the model using 2 different settings. The option 1 was the one with optimizer Adam, loss was sparse, categorical cross entropy, and the metrics were accuracy. So yeah, and the option B was to use RMSprop and the categorical cross entropy and the accuracy. So after training both of them, as you can see here, I've already trained. It gave me the accuracy of 87.94 for both of them, so which I printed, and then told me to explain the comparison Fashion MNIST with MNIST. So Fashion MNIST is more complex than MNIST since it involves the clothing categories, unlike MNIST's handwritten digitals. This leads to slightly lower accuracy because patterns in Fashion MNIST are harder to learn. So question 20 here was to analyze the accuracy differences. So the differences in accuracy between configurations stem from their optimizers and loss functions. Adam generally converges faster while RMSprop performs better for specific cases like one hot encoded data. So yeah, finally I evaluated the model on test data. So option A gave me accuracy of 87.9%, while option B gave me the accuracy of 87.9%. So this was the training and testing accuracy, indicating minimal overfitting. So yeah, so this exercise highlighted the power of neural networks for image classification. By experimenting with different configuration, we observe how optimizers and loss functions impact performance. So that's all from my side. Thank you.